In this lesson, we shall focus on differential calculus and optimization. All right, so we shall also have an opportunity to focus on cubic curves or cubic graphs, but also we shall look at how we're able to use calculus to determine the maximum and minimum volumes and surface area. Okay, so we proceed as follows. Right, and look at question 7 highlights some of the most basic of concepts. And the truth is we shall work together as we delve into the most basic of notions, but also to the most advanced from bottom to top. Okay, now the first question in calculus pertains what we call first principles. So we recap on that by looking at question 7.1, where the question says determine f prime of x from first principles if f of x is minus 2x squared minus 1. Okay, there are a couple of questions you shall have a chance to do. All right, now first principles is one thing that it's very important, and it is f prime of x. Right, f prime of x is the limit as h approaches 0 of f, open bracket, x plus h minus f of x, all divided by h, like so. We have an opportunity to explore these definitions, but very carefully. And I have f of x plus h, which is minus 2x plus h squared minus 1 minus 2x squared minus 1 divided by h. So f prime of x is the limit as h tends to 0 of, okay, now let us do expansions. Okay, the couple of things we need to take note of, that if f of x is actually minus 2x squared minus 1, then f of x plus h is, in the place of x here, we put x plus h, all squared minus 1. And this is therefore minus f of x, which is minus 2x squared minus 1, so which is minus 2. You square everything here, which is x squared up 2xh. We have h squared minus 1. We perform distribution here. Negative by negative gives us a plus. I know that this one you know very well, but we begin building from bottom up. And this means that if primed is the limit, as h tends to 0, we distribute here, getting minus 2x squared minus 2 by 2, it's minus 4xh minus 2h squared minus 1 plus 2h squared plus 1 divided by h. If primed, okay, this becomes the limit as h tends to 0. So now the minus 2x squared and 2x squared cancel out, minus 1 and 1 cancel out, giving us exactly minus 4xh minus 2h squared all over h. And this is the limit as h tends to 0. Right, now we can take out the highest common factor. H alone is enough. It should not be all the common factors here, or the highest common factor. Just h is enough, so it can cancel with the h in the denominator. Factoring h from the numerator with minus 4x minus 2h, you divide everything by h, like so. And now, and upon careful examination, we're able to cancel out the h and the h, and we have the limit as h tends to 0, minus 4x minus 2h. Right, so at this point, what do we get? We have minus 4x minus 2 by 0, which is minus 4x. So that in the end, what we're then having is the following. F primed is minus 4x, and this becomes the answer. Right, so the result, therefore, is that f primed of x is minus 4x, and that is a derivative from first principles. And I know that this one is a concept you know very, very well. Let's go to the next question. I'm going to give you a chance to do some of the questions here. So, yeah, but obviously this is recorded, so you'll have a chance to watch this even after our discussion. Many days after, many moons, many years after. Right, so in 7.2.1, you determine f prime of x if it is given that f of x is this one. So this one, just to recap, it uses a notion we call the power rule. What does the power rule say? Well, the power rule is a notion we know very, very well, but it is clear. But it is also known that y equals x to the power n has the implication that dy dx is nx to the n minus 1. So now let's get to this. So we have f of x equals minus 2x cubed plus 3x squared, like so, and we need to find the derivative of this. And then it's minus 2. You bring down the 3x, then you subtract 1, plus 3. You bring down the 2, and you subtract a 1. Meaning that f prime of x equals, what is minus 2 times 3? It's minus 6x squared. 3 by 2 is a 6x. 2 minus 1 is a 1. Okay, and this gives us the actual derivative. And obviously at this point, this derivative, it's a derivative, is the derivative that has positive exponents, positive indices. And this is the answer to the question, and therefore we are most certainly done there. And there is nothing to do for the 2 marks there. Next question. Right, in the next question, we attempt question 7.2.2, and now this involves some radicals in the denominator, and we have 2x equals, or y equals 2x plus 1 over the square root. So y equals 2x plus, so square root of 4 square root of x. Okay, the square root of 4 is 1/2 the square root of x. So which is 2x plus 1/2 x to the minus 1/2, like this. So we have this, meaning dy dx. Okay, now let's find dy dx. So dy dx, now we perform the derivative of the x, and therefore it becomes 2 times 1 x to the power 1 minus 1 by the power rule, plus 1/2, we have this one to the power this minus 1. So which means dy dx, 2x, 1 minus 1 is 0. Minus this, which is minus 3/2. Okay. This is exactly what we have. Let us analyze this together. Right, so upon careful examination, we're able to see that this is the result we're getting, but it means in turn, dy dx is x to the power 0 is 1, provided x is not equal to 0, and we take it as 1, with x being arbitrary required, but x not 0, we assume. And this is minus 1/4, 1 over x to the 3/2. Okay, we write our answers with positive indices, and therefore this is essentially the answer to the question. This is essentially the answer to the question, and therefore we are done. But we can write our answer as dy dx is 2 minus 1 over 4x to the power 3/2. And this here is the result. It is the answer to the question, giving us dy dx equals 2 minus 1/4 divided by, minus 1 divided by 4 x to the power 3/2. Just take note of that. All right, so obviously I know that this is very, very easy for now, and move to the next question. Now the graph of y equals, f prime of x has a minimum turning point. I'm going to give you this one to see what you can think about it. Right. So the graph y equals f prime of x has a minimum turning point at 1 and minus 3. Okay. And I'm going to give you this one to try, and then you'll give me the answer. I'm hoping you have your book there. Normally have your book, have your pen, and you can scribble. You can try some of the questions, but yeah, I'm not gonna obviously give you all the questions to try because we run out of time, you know, and we need to just move. And you can only try some of the questions because I'll be interested in seeing what you can do. So I believe you have your scrapbook next to you, or your usual examination pads, right? So determine the values of x for which f is concave down for 2 marks. Okay, I'm giving you 2 minutes to try this one. 2 minutes to try this one, and then you let me know, because yeah, I must keep you active. I must keep you thinking. I know you can get this right. In any event, it will be very interesting to see how well you can perform. It will be very interesting to see how well you can actually be in a position to perform here.
Can I see the original question?
The original question, okay?
Mm.
Right. Here is the original question. Here is the full question. So this question was given out of 13 marks. Okay. We shall do it together, but yeah, some of the questions I'll just drop in and just be interested in seeing what you can do. This is the full question. Okay, but obviously our interest is in, because we've already done the rest, and our interest is seeing what you can do with 7.3. I'm interested in seeing what you can think about it. The graph y equals f prime of x has a minimum turning point at the points 1 and -3. Determine the values of x for which f is concave down. Right, it will be very interesting to see how well you can be able to perform here. Let us see what you can do. Sometimes, yeah, I know some of the questions are a bit tricky. Some of the questions are a little bit tricky, a little bit twisted, but they are there to build you up. They're there to build you up. All right, they're there to build you up. So, yeah, let's see what then you're able to do here. Let's see what you're able to do here. Yeah, I'm sure about 2 minutes is done now. What do you think? Is it too tricky? I don't know. I'm just giving you a chance to see what you can do. Some of the questions, some of these I'll just throw in. You know, some of these I'll be like, okay, too obvious. Maybe you can just pass. Yeah. What's your thought on this one, Noah? Your
You
thought?
get the first. You get the first derivative f prime x,
Yes.
and then you substitute 1 in the
Yes.
way the x, and then you
I
get
agree.
-4.
Yes.
You get a gradient of -4.
Okay, I get your point. Yeah, but remember, you see, that's fine because I'm just testing you. You'll forgive me. I test you because you're alone here. There's nobody else except me and you. You know, but now, what you need to realize that 7.3 is nothing to do with the questions above. You know, so 7.3 is only,
It's a, oh, okay.
yeah. So it is not connected to any of those.
So
It is just a
it's
question on its own. But you see, the tricky part with the question is that the f function is not explicitly given in 7.3. So you're not told what f of x is, but you're just given that the graph y equals f prime of x has a minimum turning point at 1 and -3. And obviously you don't analyze what that is supposed to mean, because what is the function f of x? Is it x squared? Is it anything like that? Okay, yeah, determine the values of x for which f is concave down. So yeah, okay, I'm just testing you. I want to see what you can think about some of these questions. I know some of these questions are there to test your reasoning, and yeah, I'm gonna throw in some of the questions. Please forgive me if I happen to do that. Okay, here's the question now. I just broken it down a little bit just to create a little bit more writing space. Okay, right. So the graph y equals f prime of x has a minimum turning point at 1 and -3. So it means that we need to consider this graph y equals f primed. So it has a minimum turning point. So if you look at this graph,
it's a quadratic graph.
it's a quadratic. Well done. It's a quadratic graph, which has a minimum. So if a quadratic has a minimum, it means the shape is like this, and it has a minimum turning point there. So this is the turning point of the graph. It is the turning point. Okay. Now you've determined the values of x for which f is concave down. All right, and now we need to analyze what that is supposed to mean. Okay, right. So now we need to be able to deal with f right now. We need to be able to deal with f of x to say if f prime of x is like this, how is the graph of f supposed to be? Obviously, yeah, okay. F concave down, what does that mean? It means that f double primed of x is what? Is negative. Because if the second derivative of f is negative, it means that f is concave down. Just want to write that one. So there are two things here. Okay, there are two cases. So if the second derivative is negative, it means that f is concave down. Okay, that is the implication. Okay, now, so what then is the meaning of this? If somebody comes and says, then the second derivative of f is negative, what would the second derivative of f being negative mean? That would mean that the slope, this describes the slope of f prime of x. So the slope of f prime of x is negative, and that means the slope of f prime of x is that. So this would have to do with f double prime of f being negative, and therefore that will only happen when we are going this side of the graph, because that is when this is negative. Otherwise, the slope is positive here of f double prime of x, and therefore it means, and this happens when x is less than 1. It's only when we are to the left that the slope is negative, because if you are given the f prime of x graph, and now somebody comes and says to you, determine the values of x for which f is concave down. What does concave down mean? Concave down means the second derivative is negative, means f double prime of x is negative. Okay, I mean, similarly, in a block here, we can say if double primed of x positive, it means f is concave up. Okay, if double prime of x, it means f is what? Is concave up. Any question on this now? And therefore the answer to this question is x.
So can you explain again?
Okay, good. I'll explain again, and I'll explain from the first sentence of the question. The first sentence of the question says the graph y equals f prime of x has a minimum turning point at 1 and -3. So now dealing with the minimum turning point of one graph, it means we're dealing with a quadratic. And the quadratic has a minimum turning point, means its shape is like this, because if it had a maximum turning point, it was going to be this way. Okay, right, so it has a minimum turning point, so this is what we have. And the minimum turning point is clearly at what point? It's clearly at the turning point, 1 - 3. So this is the graph the examiner is describing in the first line. In the second line, the examiner says determine the values of x for which f is concave down. So if f is concave down, what does it mean? Okay, f is concave down means f double primed is less than 0. F concave down means f double primed is less than 0. So what would f double primed mean? Well, that would mean that now you are dealing with this graph here. You are given this graph, but you must find its derivative again. So you have f prime that is given to you, and then you are finding its derivative again. And this in mathematics describes the slope of f primed of x. It describes the slope of what? The slope of f primed of x. And now, because the prime means, what is this? What is the meaning of this? If somebody writes y equals f prime of x, this means the slope of f of x. This means the slope of what? Of f of x. Because the prime means slope of f of x. So if it's double primed now, the double primed, it means that we are dealing with the slope of this graph. Okay, so the slope, now we're looking at the slope of this graph. This is the graph here given to us. So if you want to find its slope, we find its derivative. And then the slope is negative here. When is the slope negative? The slope is clearly negative when we're going down here, but it's positive when we're going up here. Okay, So the examiner is saying determine the values of x for which f is concave down, meaning where f double prime is negative slope. That would mean therefore that the slope is negative to the left of 1. To the left of 1. Because at 1, it's something else that happens. But to the left, it is negative. But obviously at 1, you would see that the slope is what? The slope is 0. The slope is 0. So ideally then the slope is negative to the left of 1. So x is less than 1. Try to understand it. It's a little bit tricky. It's a little bit tricky because there's no function that's given here. It's just words. It's just words, just 2 sentences, that's all. Okay, try to reason of this question. This question was set in June. It was set in June 2023. It was set in June 2023. This was given to the students and to juggle with it. And some students found it tricky. Some students were like, hey, it doesn't have anything to do with any function f. Where's the function f that examiner is speaking about here? They're just saying y equals f prime of x, and that's all. And then we must solve for x. How can you even find x here? You know? Okay, let's move to the next question. In the same year, at the same time, in June 2023, they asked this question. Given f of x equals x cubed plus 4x squared minus 7x minus 10, write down the y-intercept of f. Show that 2 is the root of the equation, etc., etc. Okay, I decided to break the question down to a couple of pieces for us to digest. Okay, let's write down the y-intercept. How do you find the y-intercept? Okay, you can start with a question. How do you find the y-intercept? The y-intercept will let x be 0. I know that no one knows that very well. So if x is 0 here in the place of x, you'd have f of 0, which is 0 cubed, plus 4, 0 squared, minus 7, 0 minus 10. And f of 0 is minus 10. So now this is the y-intercept. So by the y-intercept, therefore, you can then say, therefore, y equals minus 10 is the y-intercept. Any question on this one there? No, that is question 8.1. Okay, I believe, obviously, I know that this one is very, very easy. There are a couple of questions that will be a bit tricky on concavity and other things. So you can always be in a position to take note of those. Let's look at the next question, 8.2. Right, 8.2, you need to show that 2 is the root of this equation. 2 is the root of the equation f of x equals 0. What is a root? A root is a value of x. So now we are dealing with x equals 2 because x is the root, we're dealing with x equals 2. So with this one plus 4x squared minus 7x minus 10, which means that f of 2 is 2 cubed plus 4 2 squared minus 7 2 minus 10. What is 2 cubed? It is exactly 8. Okay, and then 2 squared is 4, 4 by 4 is 16 minus 14 minus 10. Right, so obviously, I mean, if you have this, 8 plus 16 is 24, minus 14 minus 10 is minus 24, and 24 minus 24 is a big naught. And this is enough. So because to show that 2 is a root of the equation, it means that we just take x equals to 2 because x is a root. Taking x equals 2, meaning x equals 2 in the equation of f, and therefore we make every x 2, okay, in the equation, and we've done that. And the result must be 0. Because the result is 0, it makes the equation true. It makes the equation true because the equation is f equals 0, and therefore it means that x equals 2 is a root, or 2 is the root of the equation there, because it makes the equation true. If f of x was equal to 7, we would require that f of 2 be 7 for the equation to be true, and for that to become a root of that equation. Okay, so we have exactly that. Okay, we're dealing with roots. Roots make the equation true there. We're done. So we continue. Next question. The next question is 8.3. Hence factorize f of x completely. Hence factorize f of x completely. Okay, so now let's factorize these completely. Right. We continue then with this. Right, so in 8.3, we need to perform a factorization. Let us perform a factorization. To perform a factorization of these, we have two things that we use. There's something we call the long division method. What we call the long division. Long division algorithm, or the long division method. Okay, so minus 10. So we have already said that x minus 2 is sort of the, it is the, so x minus 2 becomes a factor because 2 is it's a root. So if you have therefore now divide x cubed by x, you get x squared. X by x squared gives us x cubed minus 2 by x squared gives us minus 2x squared. And you actually introduce a minus outside parentheses like this. X cubed minus x cubed gives us a 0, and you distribute here, giving us plus 2x squared plus 4x squared, giving us 6x squared minus 7x. We have 6x squared divided by x, which is actually plus 6x. We have x by 6x, which is 6x squared minus 2 by 6x, which is minus 12x. And we subtract this, giving 0. This is 12x minus 7, which is actually 5. X minus 10. So if you have 5x divided by x, you have a 5. X by 5 is 5x plus minus 10. 5x minus 5x is a 0, and this is 0. Okay. So now, because you need to factorize this completely, factorize f of x completely, and therefore that would mean that f of x is the same as what? It's the same as x minus 2 as one of the factors, and then you have x squared plus 6x plus a 5, like this. And now this is not yet a complete factorization because we still can be able to factorize the quadratic, meaning we have f of x and we have f within x minus 2 parentheses, and then we have x plus 5 and 1. 5 and 1. So obviously it's a complete factorization. It's a complete factorization, and then we're done. But now, I mean, pay particular attention to this. This is not the only way to do this. There's another method we call the synthetic division. Right, so synthetic division is also another method we learn. Now, synthetic division is a method that must be understood and that must be celebrated. We draw a little table like this. Right, so if this is the table, what do we then have? What do we then have? Okay, we have 2 as a root. And then we take the coefficients of this. 1, 4, minus 7, minus 10. You drop the 1. 2 by 1 is a 2. And then after you drop the 1, multiply 2 by 1, you get a 2, and you bring it up here. And now 4 plus 2 gives us exactly 6. 2 by 6 gives us 12. And minus 7 plus 12 gives us exactly 5. 2 by 5 is a 10, 0. Right, so, and this means that here we had put the x cubed, x squared, x constant term. So, I mean, what we're able to see here, therefore, is we had put these, but now this one is going to be associated with an x squared, x, and then constant. So f of x equals x minus 2, and then we have x squared plus xx plus 5. Okay, but obviously upon careful examination, because now this is x squared plus 6x plus 5 from the synthetic division method, and then now we're able to see, therefore, that this is x minus 2 in parentheses, and then this is x plus 5, x plus 1. Okay. So we continue right now to solve more problems. Right, so yeah, we continue right now to solve more problems there. Any question, I believe, here? Is there any question? No, no question here. Perhaps everything is clear. Too obvious. Right. Right. So we continue. Okay. Next question. Right, so yeah, we have already dealt with these two questions, or these three questions, and then now we continue to try the next one. And the next one is not at all a different question, so it is something very, very easy and something very, very straightforward. Let us spend some time to understand this, but also unpack the next series of questions that must be learned. Next point. 8.4, if it is further given that the coordinates of the turning points are approximately at 0, 7 and minus 12,6 and minus 3,4 and 12,8, draw a sketch graph of F and label all intercepts and turning points. There's something we need to remember about this function, that it was actually exactly this one here, x cubed plus 4x squared, x cubed plus 4x squared minus 7x minus 10. X cubed plus 4x squared minus 7x minus 10. So now to obviously have a rough sketch of this, we've already got the x-intercept, and then we have already got the y-intercept, and we remember that we said the y-intercept is y equals minus 10, and then the x-intercept. So it is x minus 2, x plus 1, x plus 5. Okay, and yeah. Right. So xy, all right, the x-intercept will be minus 1, minus 5. So we can put first minus 5, and then because if we make these 0, then which gives us the x-intercept, you'd have 2, minus 1, minus 5. Right, so we have minus 5, minus 1, and then 2. Okay, and then the y-intercept is at minus 10. Okay, so let us just sketch this very quickly. So if this one here is at minus 10, what then do we do? Right, so in the end then, you'd have that we have this, we have exactly that. Okay, but now look, the graph that is having a positive shell would have a minimum. So there are two possible shapes. So if you have f of x equals ax cubed plus bx squared plus cx plus d, and then there's f of x equals ax cubed plus bx squared plus cx plus d. Okay, there's a case where a is negative, there's a case where a is positive. So you see, if a is positive, it means therefore that at this point you would have a minimum vertex, and then it does this. But if a is negative, you start drawing it from the end, it has a maximum vertex, and like in the case of a parabola. So if a is negative number, then you'd have a maximum vertex, and then it goes this way. Okay, so okay, we go like this. We go like this. And then okay. Now, so we have 0.7 minus 12.6 minus 3.4, 20.8. All right, so this is the shape we have. This is exactly the shape we most certainly have. And we'd have this rough shape. And then this shape is the sort of the desired shape for this question, because it's sketch a graph of f and label all intercepts and turning points. And we've labeled all intercepts like here, the x-intercept, the three of them, and the y-intercept, and the turning point. And the turning point. Next. Now use your graph to answer these questions. Right, let's look at the graph again. I mean, we already have a rough sketch of it. Okay. Okay, two. Okay, yeah, we have this. And yeah, okay, the turning points. Okay, because we already have drawn the sketch, but I'm just trying to draw the graph here so that we can have a quick review on it, but also have a fair chance to. Okay, so it is 0.7. All right, so all right, so yeah, let's this is the graph of f. Okay, if this is the graph of f, then what do we then have here? We're able to see that this is the graph of f. Then you need to use your graph to determine the values of x for which the first derivative is negative. And if the first derivative it means negative, it means that you have negative. It means you have negative slope. Okay, we have negative slope. When is the slope negative? When the graph is running down slope. Down slope negative. Positive, positive, positive. Okay, the slope is positive, positive slope, positive, negative, negative. So now use a graph to determine the values of x for which the first derivative is negative, meaning the slope is negative. So if the slope is negative, what do we have? Well, for what values of x? I'm sure you can get this one right now. You can get this one right. So determine the values of x. What do you think the answer is to this one now?
X is greater than -3, comma 4, but less than 0.7.
Well done. So x itself is greater than 3.4 and less than 0.7. So we are between the minus 3.4 and 0.7 because the slope is negative. Now, okay, well done. If you don't want to write it like this, you can also say x is an element of the interval. Minus 3.4, 0.7. Okay, the gradient of a tangent to f will be a minimum. The gradient of a tangent to f will be minimum. What does that mean? Okay, so we need to find the values of x. So if the gradient of a tangent to f will be a minimum, so what does that mean? I'm giving you like 2 minutes. No, it's 2 marks. So I'm giving you like 2 minutes. So I'm giving you exactly 2 minutes. What is your take on this one now? Or I want to see what you're gonna do. I want to see what you're gonna do now. Or right. So your take now. What do you think the answer is to this one? Okay. Let me know when you're done, please, Noah. Just testing you. I want to see what you're gonna do. I want to see what you're gonna do. I want to see what you're gonna do.
I got an answer of -4/3.
Okay. Well done. Well done, well done. So obviously use the graph to determine the values of x for which the gradient of a tangent to f would be a minimum. And now if we find the gradient of a tangent. So first, let us be in a position to deal with the function f of x, which is x cubed plus 4x squared minus 7x minus 10. And then let's find the gradient of a tangent. This would be the gradient of a tangent. So the gradient of a tangent is f prime, which is 3x squared plus 8x minus 7. Then we want the gradient to be a minimum, so we must differentiate it again. So in other words, we can write it in many ways. I'm going to write it in 2 ways. So it means that we must have f primed, and then we find its derivative, which is f double primed of x, and this is 6x plus 8. So the derivative of this is the minimum. So we must, for minimum max, we must equate it to 0. And now this is exactly 6x equals minus 8. We divide by 6 both left and right. And so this is minus 4/3. And this is the answer to the question. This is exactly the answer to the question. So we're saying the gradient of a tangent to f will be a minimum. So the gradient of a tangent to f is the minimum when the gradient itself is derivative 0, or derivative naught. Okay. Derivative naught. Okay, yeah. My point is it confirms the fact that your answer is correct. Okay, because the answer is therefore minus 4/3, and it is exactly the answer there. It is exactly the answer there. Next point. Right, so, okay, I would keep it here. I'd be interested in doing the 8.5.3 on the same slide because on the same board because the graph is already here and we can be able to see the answers. But now if I move to the next slide, then I'll have to draw the graph again. So let's look at this one. I'm giving you like 2 minutes. This one is 3 marks. Okay. So what do you do? What do you do here? What do you do here, Noah? Let's see what Noah can do here. Noah can do here. Noah can do here. Noah can do here. Right. A little bit tricky, this one. Let's just create a new slide for it. Let me just draw something rough and do this one. Okay, so all right. Okay. Okay, now this is the sort of graph we're having. And let's see. We have put the things. And then this one. So which is minus 12.6. This is what we have. Okay, yeah, this is the sort of graph we're having. But now the question we're asking is now we need to solve this one. But we also know that f double primed of x equals 0 means that x is minus 4/3. And now we can draw a line like this and put here minus 4/3 and then be able to remember something about the fact that, okay, f of x is that one, but what is the first derivative? Let us find the first derivative. So the first derivative is 3x squared plus 8x minus 7, and then the second derivative is exactly 6x. Okay, this is 8x. This is 3x squared, and then this is 8x. Right, this is exactly 8x. We found the first derivative of this. The second derivative would be 6x plus 8. Okay. So, okay, look. Right, so yeah, if this is 0, that means x is minus 4/3. All right, so we are. Now, look, if x is this, then it means we have the derivative. Okay, but now let us look at the expression for f of x, f double primed, okay, which is exactly 6x plus 8. Now let's take a number bigger than 4/3, like 0. 6 by 0 plus 8, which is a plus. Take a number to the left of minus 4/3, maybe like, this is like minus 4/3 is like minus 1 and 1/3. So maybe we can take like minus 5. Okay, maybe even minus 2 is okay. 6 times minus 2, because it is to the left of this, which is minus 12 plus 8. And minus 12 plus 8 is actually exactly minus 4. It's exactly minus 4. Okay, if this is a -4, then what does it mean? It means that the function is concave down here, and then it means the function is concave up there. Okay. So this is the shape. So we characterize the shape as this one because the second derivative is negative. And then we then say, wherever the second derivative is negative, it is concave down, concave down, concave down, concave up. Okay, concave up and then concave down. Okay, right. So now let's just see what we have here. Okay, this gives us the analysis of this, and therefore, yeah, for the 3 marks, what then is the answer to this? What then is the answer to this? What then is the answer to this? Right, so obviously at this point, we look at this and
Yeah. So can you
what do you think?
explain again? Can you
Okay.
explain again?
Oh, okay, that's fine. Right,
I
because
don't
I was
understand
oh,
that part,
this
second
part,
derivative.
the second derivative part.
Mm.
Okay, yeah, because what I was
Because
looking,
the first derivative is the gradient, right?
yeah, the first derivative is the gradient of f.
So
So
for
this
the
one
second
is the
derivative, what's
slope,
relevant?
of f, or the gradient of f.
So for the second derivative, it's concavity.
Yes, the second derivative is concavity.
So
So now,
what do I look? How?
yeah, okay,
Yeah.
because now we're drawing this sine table. Okay, we're drawing this. This is called the sine table. Right. So if we're drawing the sine table, then this sine table is positives and negatives. So which means that if f of x, f prime of x is, okay, f double primed. What is f double primed? Okay, you got f double, we got f double primed to be 6x plus 8, and then that gave us x equals -4 out of 3. And we put it here on the number line, and we're able to see to the left of -4/3, we have negative, and then to the right of it is plus. Okay, so now, obviously, okay, why is it plus here? We want to get the sine table of this, so we want to complete the sine table. To the right of a negative number, because this -4/3 is negative, to the right of it is like 0. Put here in the place of x. 6 by 0 plus 8. What is 6 by 0 plus 8? It's exactly 8, which is plus, which is a positive number. Even whatever number you can choose to the right of minus.
So solve for the second derivative, you have to solve for x.
Yes, for the second derivative, you need to solve for x, which is what we did, and we got -4/3. And then we do the sine table. Yeah, and then we do the sine table. Right, because the sine table is going to show us the concavity. Because now you're going to have a chance to see where it's going to be negative or positive. You see, with f primed of x, it is the gradient of this, so it's easy to see. Okay, I mean, even the second derivative can have a way to see, but one way to see the second derivative if it's negative positive is to do the sine table. Okay, but for the function f, you can see the slope. What is the slope? The slope is negative, and then the slope is positive. And then here the slope is positive. Okay. Okay, the slope is positive. And the slope is positive. Okay. If the slope is positive, positive. Now, we're dealing with the slope. Because I want to answer this question. So to answer this question, you must just use positives and negatives. So obviously what we're having here is f primed. Okay, so this is negative and this is positive. And then here it is positive and this is negative. Okay, so there are two cases that when you multiply the two numbers here, you have a negative. So multiply two numbers out of the functions. When you multiply them, you have a negative. So it's either if you have a negative times a positive, or because if you multiply a negative by a positive, then you have a negative is less or equal to 0. And a positive times a negative, you'd have a negative which is less or equal to 0. In which case, therefore, what we're having here, we just need opposite signs. Okay.
So is there another way
Yes.
to
To the
work it out?
question.
Yes, or is it?
Yes, surely there is another way to work the question out, because now the only thing that can be tricky is to look at where the second derivative is going to be negative or positive just by looking at the graph. So that one is going to be a bit tricky because you need to position minus 4/3 here. And minus 4/3 you need to put in the graph. Minus 4/3 is like minus 1 1/3 and 1/3. Okay, so it's like somewhere here. Okay, so it would be like here. Okay, which is minus 4/3. Okay, so the minus 4/3, which is, this is minus 1, and therefore this one would be like minus 1 1/3. Okay, now let's come. Okay, we shall have a way to just quickly see that. Now, here, if you're to the left of the minus 1/3, and then you'd have negative, and then to the right of it, you have positive. You have positive. And then to the left of it, you have negative. Okay, like this. So let's analyze these and have a way to see these, because you need to have the two comparisons. Let's look at what happens now, because our determining factor will be the minus 4/3. If you go to the right of minus 4/3, you'll see that the first derivative is the slope of f. First derivative is negative here, so it is negative here to the right of it. But it is negative here when the second derivative is positive. So which means that it's what we want. The slope of the f function is negative slope of the f function, but the second derivative is positive, so it's what we want. But where does that stop? Now it stops here where you have 0,7. At 0,7, you have that the f function has a negative slope, but the second derivative is positive all the way. So it's up to that. So where does it start? So your answer is going to be minus 4/3, which is less than 0,7. Okay. So now at this point, now, okay, it's one part. What about the other side? Okay, yeah, it's going to stop here, because you have negative slope here, but the other one is positive. So it's negative times positive, and then you have negative times positive, which is negative. Now let's look at the part where the first derivative is positive slope. This one is going to potentially stop at the turning point, because the positive slope here is up to the turning point, but this second derivative is negative. So, but it's going to stop here, because at this point now, you have that the slope of f is positive, and then the second derivative is negative, and then it's going to stop here, because at the turning point, then that is where the positive slope is stopping. Then the slope starts being negative on the graph. So, which means that you'd have to take it from x less than minus 43, or okay. So this is sort of the answer. This is sort of the answer to it. Okay. And now this is the answer. And we're done. The thing about it, I mean, there are many ways to do it, but the most practical of ways is to say, when is the second derivative negative? But now, for the second derivative, you need to do the sine table. What about if the sine table is not the best? How else can you see that the inflection point? So by looking at the graph, you can see the graph here is concave up. So if this point here is minus 4, some of the things are tricky to see, minus 4/3, then it's concave up here. And then this side here is concave down. Okay, so this is sort of what is happening, but if you can be able to see that. And then obviously whenever it's concave up, it means that then it's positive second derivative, negative second derivative, etc. But this sort of becomes the conclusion. I mean, another way to do this question would be to say, you want to know where the second derivative is negative, positive, draw its graph. This is a linear function. It's like drawing the graph of y equals mx plus c. Then you can just draw this graph and then be able to see, how does this graph look like? Let's see. Okay, if x is 0, y is 8. And then if this is 0, x is minus 4/3. Okay. Which means y equals 6x plus 8. Okay, so if this is the kind of graph you have, then when is the graph negative? It is negative to the left of this. So it's negative when it is below here, and the graph is positive here. Okay, that's another way to see where the second derivative graph is positive, negative, you know? Yeah, maybe it's not, but this is sort of the ways to, and therefore, after all, this will be the answer to the question. But yeah, think about it and see what you can pick from these now. Very, very interesting. Right. Let's see what else can be done
So
here.
can you explain again
All right, let me explain again.
this one, the graph,
The
straight
graph. Okay, this one. This line, the sine table.
No,
Okay.
the second one.
Oh, this one. Okay, right, let's look at this graph. Right, to explain this graph now, we can just draw the graph of the second derivative function, because the second derivative function is a linear function, which is of the form y equals mx plus c. This allows us to see the concavity. Obviously, this one is a straight line, but where is it concave? You just have to look at where it is negative or positive as it is drawn. Where is it negative? It is negative surely when you are below the x-axis, and it is positive when you are above the x-axis, because y is positive there. So now we are drawing this graph and assuming that this f double prime of x is like y, so that we have y equals mx plus c, and y equals mx plus c. This is the graph. And then now with this graph given, you need to find your x and your y-intercepts. Your x, when x is 0, you have y equals 8. You have y equals 8, which is this one here. And then when y is 0, you have x equals minus 4/3. So minus 4/3 is this one, which is actually the x-intercept. And then you connect to the x-intercept, the y-intercept, and that gives you the graph of the second derivative function. And this function tells us a couple of things, but it tells us when is it the second derivative positive. So positive, it means that the original function will be actually concave up. So, but it is positive here, just from the intercept here, everything is positive here. But from the intercept here, everything is negative. Everything is negative. Everything is negative. Okay. So in the end, what do we want? We just need to know where the second derivative is negative or positive. So we can use the sine table, which is the most popular, or we can just draw the graph of this function and then compare these two graphs, because now we need f primed of x. The f primed, we can just be able to see whether f primed is negative or positive. The slope of this is positive here. We can just read f primed from the original graph of f by looking at where it's going up slope, down slope, up slope. And then also we're able to see the second derivative. On the second derivative, it's when we can draw this one and be able to see, oh, it's positive all the way from minus 4/3. If we want, we can even draw it on the same system of axes. You know, can draw it here. Draw it here, because this is it's exactly that graph there. And if this is the graph, you can draw it is minus 4/3 here, minus 4/3 and 8. Minus 4/3 and 8. Right, so you can be able to see that, okay, this one is positive, and this one is negative below, and then be able to see, you need opposite signs. Negative, positive, it's what we want. Okay, negative, positive is what we want. So you have negative, positive, that's what we desire. But up to this turning point, because the turning point, the derivative is negative, is rather zero as the turning point. Okay, that's something that you can, try to think about it and make sure sort of can make sense of this. But yeah, there are many other questions we shall spend time on it. We shall spend time on and make sure that we are able to understand everything very, very well. Let's look at the next question. Let's look at the next question. A little bit tricky. Okay, the next question is even much trickier. Much trickier. It's about a wire. And now we're going to participate here. This one is an optimization question. Right, so let's look at the optimization question. A wire 12 meters long is cut into 2 pieces. Optimization. A wire 12 meters long is cut into 2 pieces. One part is bent to form an equilateral triangle and the other is square. A side of the triangle has a length of 2x meters. Okay. Write down the length of a side of the square in terms of x. Okay, let's look at this one. Now let me give you like 2 minutes. This one is 2 marks. Let me give you like 2 minutes. I want to see what you're gonna do, and then we're gonna discuss it together. Try it now. Okay, I'm giving it to you because it's like a different, it's a different it's different, it's not routine. You know, it's quite an unseen question in the way it's given. It's unseen. So let us see what else we need to do here. Let us see what else we need to do here. Right. See what else you ought to do in this case. Let me know when you're done, please. And then we're going to discuss the answer together. I'm just giving you some brain teasers, like some pop quizzes. You know, you're not expecting me to ask you to do anything, but I'm just like, okay, just try this. And then there are many questions that I'm going to give. And then there are tons of questions I'm yet to give, like tons, volumes and volumes. That are gonna, because we need to we're getting to that phase where I'm just gonna give you a plethora of questions, and you can just like swim into a lot, tons and tons, and I'm gonna be marking them. Okay, so those are the kinds of things that we shall be doing. So, get yourself prepared and get yourself ready, because it's gonna be happening. Let me know, please, when you're done with 9.1. I want to see what you're gonna do. I want to see what you're gonna do. I want to see what you're gonna do. 9.1. I want to see what you're gonna do. Okay, how far now?
I'm still
Okay,
I'm still
okay, that's fine.
busy.
That's fine. That's fine. Okay,
I'll tell you
okay.
when I'm done.
All right. Thank you. That's okay. That's all right. I want to see what Neville is gonna do here. Obviously, I also don't want the recording to like have no sound, because whenever you're watching, it's just gonna go quiet when we don't talk. And when it goes quiet, then you're like, okay, what was happening here? It's like there's no sound, no one is writing, no one is talking, so there's like absolutely nothing. It's just a total vacuum. So It is very, very important that obviously I narrate. And the reason why I narrate is to make sure there's a bit of sound so that when you watch this video, it's not too quiet, because a very quiet video is a boring video.
So for
Yes, what is that? Yeah?
I'm confused when they're saying that it was bent.
Yes, it was. Okay, there's a part where they're saying it was bent because a wire 12 meters long is cut into two pieces. So someone takes a wire that is 12 meters long and they cut it into two pieces. One part is bent to form an equilateral triangle. So they're just bending it to form a triangle. And the other part, they bend it to form a square. So they're just bending the wire to form an equilateral triangle. And then the other one is used to form a square. A side of the triangle has a length of 2x meters. And then now write down the length of a side of the square in terms of that. Okay, never mind. I'm just teasing you, and then we're gonna do the next one. But I'm just interested in seeing what you can do. All right, let's do it together. Okay, so there are two things here, and somebody's taking this wire, and this wire has length 12 meters. Okay, we're discussing together. Okay, here's a wire of length 12 meters. And this wire of length 12 meters is suddenly cut. Somebody does the cutting and they cut. They did not say they cut into two equal parts, but they're just cutting it. Huh. But into two pieces. One part is bent to form an equilateral triangle, and the other is square. So they take maybe these parts, and they form a triangle with all sides equal. And the other is square. Like this. Okay, a side of the triangle has a length 2x meters. So this is 2x, 2x. Remember, the word equilateral triangle means all the sides are equal, and therefore, but a side of the triangle has a length 2x. So it means that each length is going to be like 2x. Okay, so we just put 2x everywhere for the triangle, But for the square, we don't know, and that's where the trick is, because they're saying now write down the length of a side of the square. If we know the side of the triangle, it's this, and then what about this side of the square? Okay. Now this means some things. Okay, so the question is, how much length of this wire was cut from the 12? 2, 4, 6. So 6x perimeter. So there's a perimeter of the triangle. Perimeter of triangle is 6x. So the perimeter of triangle is 6x. And then simultaneously, you'll focus on the perimeter of the square. The perimeter of the square. 12 minus 6x. 12 minus 6x. So it means that if this one is 6x, they've taken part of this wire and they formed this triangle. But if we add the length of the triangle that we cut from this, they form 6x in length, and therefore it's 6x. And therefore this one is 12x. It's 12 minus 6x. 12 minus 6x. 12 minus 6x. So it means, therefore, out of the 12, we remove 6x to form the 2, 4, 6x for the triangle. And then the remaining part would therefore be for the square. And for the square, now we're left with this one, 12 minus 6x. Out of the 12, we have removed the 6x, which we used to form the triangle. And then now the remaining part, the remainder is 12 minus 6x, use it to form the square. But now we can be able to find the side. So if we add all these for the square, this is the remaining part we can use to form the square. But now from this, we can be able to write down the length of a side of the square and the full length. length of a side of the square. Length of a side of the square would be the same as you take the whole wire available, but it has been cut into two pieces. But now one piece is as used to form the equilateral triangle with length 2x, or it's 6x, and then the remaining part is out of the 12, we remove 6x, and then we have the remainder. But with this remainder, the remaining part of the wire, we divide by 4. Okay, so 12 divided by 4 is what? Is 3. So yeah, so it's 3. And then here is 3 out of 2x. So which means that the length of the side of the square is 3 minus 3 over 2x. Okay. So because they want to write down the length of a side of the square in terms of x, so we take the remaining length of the wire, we divide it into 4 parts. Why 4? Because the square has 4 sides, and therefore each side is 3 minus 2 that, 3 minus 2 that, 3 minus 2 that, and then also this one here is exactly 3 minus that. Any question, please? Think about it. Think about it. And make sure you understand. Make sure you understand. Okay, any question
So
now?
I'm trying to understand this. Can you please
Explain
explain
again.
again?
All right, that's fine. But obviously, it's one of those questions unseen. Sometimes they just throw in this question to test your logic and to just ability to create logic from a story. Now, we start by reading the given information. A wire 12 meters long is cut into 2 pieces. So we take a wire whose length is 12 meters and we cut it in the middle or just somewhere into 2 pieces. One part is bent to form. So we take one part, we form an equilateral triangle, and we take the other part, we form a square. So one part is bent. Because it's bent, they form an equilateral triangle. And then, and the other a square. So this other one now has 4 vertices, like this. A side of the triangle has a length of 2x meters. Okay, so this other part, so it is 2 pieces of the wire. Here is one piece of the wire, and there's another piece of the wire. There's another piece of the wire. Okay, there's another piece of the wire. Now this one we form an equilateral triangle. We form a triangle there. Okay, if you form the triangle, what then happens? The examiner tells us that a side of the triangle has a length 2x meters. Okay, so in other words, we form an equilateral triangle and the length is 2x meters. Okay, so 2x, 2x, 2x. And then there's another part that is used to form the square. The question is, they did not tell us the length of the side of the square. It's only the triangle they say where they said the length is 2x meters for each. Okay, equilateral triangle means all sides are equal in length, and therefore, but the examiner was kind to us, and they said, okay, the sides are equal of the triangle, but note that each side is 2x meters, so we can put 2x, 2x. But the question is, what about now the examiner saying, write down the length of a side of the square in terms of x. The examiner saying, deal with the square yourself. So if we know that the triangle has 2x, 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 what about the square? So we must think that, okay, this wire is cut into 2 parts, but we know that we have the original length of 12x meters, and we cut 6x. So 6x is used to form the triangle. And then what about the remaining part? What is the length of the remaining part? If out of 12 meters, you remove 6x. So it means that the remaining part is going to be 12 minus 6. Out of 12, we subtract 6. 12 minus 6. 12 minus 6, we then take the 12 minus 6, we use it to form the square. So the perimeter of the square is going to be out of the whole 12, we subtract the 6x that was used to form the triangle, the equilateral triangle. And then with the 12 minus 6, we must form a square. It means that this 12 minus 6 must form 4 equal sides. The square has 4 equal sides. So we must divide this into 4. So we take the 12 minus 6x divided by 4. And then we have 12 divided by 4 is 3. And then here we have 6 divided by 4 is minus 3 over 2x. Meaning we have divided the 12 minus 6x into 4, meaning we must bend this wire, this other wire. We shall bend it to form a square that is all sides equal, and the length of each side is 3 minus 3 over 3x over 2. Okay, so that becomes the thing. Okay, any question now? Maybe it's a little bit thinking. You're thinking.
Yeah, I'll go.
Yes, you'll be fine. You'll be fine. Okay, good. So we've written down because the question said write down the length of the side of the square in terms of x. So for the side of the square in terms of x, we took the perimeter. What is the perimeter? Meaning the length of all the side, the whole wire. It's the perimeters that we have. It's 12 minus 6x divided by 4. And then we need to write down the length of the square in terms of x. We divided the whole perimeter because we need to bend it into 4, and to bend it divided by 4, and then it is 3 minus 3x out of 2. Next, okay, if this square is now used as the base of a rectangular prism with a height 4x meters, determine the maximum volume of the rectangular prism. Okay, let's look at the first, this one. Now, this one here, what is the length of a side of the square? So we're dealing with the side. So now we have already seen that the side of the square is.
So this topic is called
This topic, optimization. Yeah, optimization, and optimization is about finding maximum minimum volume. So
I thought we were doing cubic graphs.
Yes, yeah, definitely. We're doing lots of cubic graphs, but I decided that we also just have a sneak peek into some of these application questions. Okay, they're just going to be popping in from time to time, but there are lots of cubic graphs. Like the next question is on cubic graphs. Okay. Okay, good. Now, if you look at these, obviously the side is there for this. Therefore, if the square is now used to form a base, so you have this. Okay. Right. Right. So yeah, I'm trying to draw a rectangular prism. So to draw the rectangular prism, let's do this. Okay, so okay, here is the sort of thing we have. So now they're saying if this square is now used to form the base of the rectangular prism, so the square is used to form the base. What is the length of the so this is a square. So this one is going to be 3 minus 3x out of 2. 3 minus 3x out of 2. 3 minus 3x out of 2, etc. Okay, so yeah, it's a square that forms the base. So if this square is now used to form, is used as the base of the rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. So let us find the maximum volume of the rectangular prism. So let's find the volume. So what is the volume? Right, we know that volume equals area of base. Volume is area of base by height. So what is the area of base? Okay, the area of base, you can say it's side squared. by height. Or you can say it is length by breadth by height. But we agree that the base is a square, so the sides are equal, so it's side squared. Which is exactly 3 minus 3 over 2. 3 minus 3 over 2. The height is what? The height is 4x meters. So which means the volume, right? So let us deal with this here. So you'd have 3 by 3 giving us a 9. 3 by this one is minus 9x out of 2, which is 9 out of 4, x squared. Volume. Okay, let's come to this, multiply out. 4 by 9 by 4. Divide 2, 18. And then here, okay, it's minus 18 here. Minus 18, and then here it is also 18. And then this one, 4 cancels, giving us, okay, yeah, but multiply this is going to be squared. Multiply, yeah. Right, so yeah, there's going to be 18x squared, and then there's going to be 4 cancels out, giving us 9x cubed. Okay, the volume. What is the volume? It is 36x minus 18. 18 gives us what? It gives us a 36. How true is this? How true is this? Yes, it is correct. So it's 36x minus 36. Okay, let's deal with the volume. Which is 36x minus 36 x squared plus 9x cubed. Okay, obviously we want to find the maximum volume, so we find the prime here, which is 36, 2 by 36, 72x, 3 by 9 is 27. Okay. Okay, so you divide through by the common factor here. It would be a 9 that divides right through. And if you divide through by 9, 9 goes how many times in 36? It goes 4 times. And with the 72, here it goes 4 times. Here it goes what? It goes, okay, because 9 would divide to be 2 times there. So that will be 6 times, right? Okay, that is right. So you can actually be in a position to just verify that. So
Isn't it 8?
I think it is. It is 8, right? Okay, if you divide 72 by 9. Well done, it's exactly 8. So you therefore be able to see that here is going to be 8x. Okay, divide by 9 here is going to be 3. It's going to be 3. So, okay, yeah, we have this. And then this is 3x squared minus 8x. So you have this. And then here you have Okay, those are the factors. And then now, what are the factors that would work here? Let's see. So it'll be minus 2. Okay, these are the factors. You can spend some time to really think about them carefully, but we're able to see that x is 2/3 or x is 2. Okay, this is what we have. And then at this point, we have that the volume is this. So we shall be able to get the volume. V of x. What is V of x? Right. So V of x is this one, 36, which is exactly this one. You can write it as 36x. Which is 36x minus 36 x squared which is 36x minus 36x squared plus 9x cubed, which is 36 2/3 squared plus 9 2/3 cubed. Okay, so, okay, if you use a calculator, you can use a calculator for this one, and it's going to be exactly 32 out of 3. And it is exactly 10,67. We need to check this one. Okay, it's approximately that. Okay, so it is approximately, okay, where are we? Okay, this equals that, but yeah, it's approximately that here. Okay, right. So obviously because it's volume and this was in meters, so this is going to be cubic meters. Cubic meters like that. Okay, yeah, something that you need to take note of. Okay, let's see. Taskbar. Okay, yeah, saying now we can just check. Let's verify. Okay, we have 36, which is 2 out of 3. Okay. Minus 36. Two out of 3. And then you square it. Plus 9. So cubed. Okay, which is 30, exactly 32 out of 3. Once again, so if you do the 36, 2/3, etc., getting 32 out of 3, and then now you press the ST button, which is about 10.6 recurring, 10.6 bar, which is 10.67 approximately. And therefore, that is what we have. But now you can take a chance. Okay, because there are two values. Either x is what? Is 2/3 or x is 2. Now let's do 2. Okay, let's do 2. I'm gonna remove this one. Okay, so we're gonna do 2 here. But obviously, if you do 2 here, it's like 36x. So 36 by 2. Okay, let's move here. Okay, now you're gonna delete this one. Put a 2 here. And then We continue. We continue. Right, we continue. Right, so at this point now, you put a 2 there, and then we continue with the rest, and we're going to put a 2 there. Yeah, hello, my dear. Put another 2 there. Yes, my dear. All right, yeah, yeah. Fine, thanks, my dear Ngizomazisa. Yeah, ngitholile isithombe, ngizosithumela kuye. Okay, thanks, my dear. All right, thank you, my dear. So now you have this one here, which is 92 cubed. And then now you can press this. So this gives us 0. It gives us 0 volume. So, but we want to find the maximum. So between 10,67 and 0, we're able to see that V of 2 is 0. So this one would be the maximum, and this will sort of be the minimum. Okay, so obviously we're interested in the maximum volume, so we're going to take the top one, and then this one is that cubed, which is, okay, V of 2 is 0, which is the minimum value. And then this one here is the max value. Okay, right. So just take note of that. Okay, it was just a creative question from the examiners, but also obviously on what you call optimization and with Bacon graphs. Looking at optimization, but with Bacon graphs. Right, so obviously I'll spend a bit more time on graphs, but we recall some of the basics as well. We recall some of the basics as well. Right, so recalling some of the basics, we're able to realize that we have the following. Okay, right. So yeah, the first question. This one I know is very straightforward. So now the first principles notion of this would means if primed with the limit as h tends to 0 of f at x plus h minus f at x over h. Just like that. So which is the limit as h tends to 0 of minus 4 x plus h squared minus this, which is minus 4x squared all over h, which is the limit h tends to 0 minus 4, which is x squared 2xh h squared plus 4x squared divided by h, which is the limit h up tends to 0 minus 4x squared minus 8x minus 4h squared plus 4x squared. We divide everything by h there, and we're able to see that at this point, what do we have? The minus 4x squared cancels out, which means, okay, okay, it's a h here, which is minus 8xh, and then you'd have the minus 8xh for these over h. Which is h, which is minus 8x minus 4h divided by h, which means h is that, which means minus xx minus minus 4h. And this is minus 8x minus 4 by 0, which is minus 8x. And obviously, we're able to make the conclusion, therefore, that at this point, what we then have is that f primed is minus 8x. Is minus 8x. So we continue right now to analyze these questions and see what we need to do. Okay, next question. Right, obviously we need to find f prime of x, if this f of x is this. Okay, this one is a routine question, is straightforward. We need f primed. So this is 2 by 3 x squared. 3, if it's the power 1, you get 3, and then 1 minus 1, which means f prime 2 by 3, which is 6x squared, minus 3x to the power naught, which means f prime, which is 6x squared minus 3. Right, so obviously this point,
2 times 3.
please come again.
You said 2 times 3.
Yes. We said that 2 times 3, which gives us a 6, which gives us a 6, and then we have the x squared there.
Oh, yeah, so now it's
Oh, okay. I thought maybe I made a mistake or something. So I was just cross-checking to see if I made an error or anything of that sort. But yeah, it's pretty much good looking, and the procedure is correct. Okay, so right now we have the necessary procedure in logic. Okay, good, should be fine. Yeah, I mean, if you look at 7.2.1, it is exactly that. So this is the answer. Let's get the next one. Okay, so now if you have dx, okay, one find the derivative of this, which is using the big dx notation. So, but first, this one, we can do it like this. We deal with the inside, which is 7x to the 2 out of 3 plus 2x to the minus 5. And you find the derivative of this one, which is 2 over 3x. You subtract a 1 plus 2 minus 5x to the minus 6. 7 by 2 is 14 out of 3. Which is x to the minus 6. Okay, which is minus 10x to the power 6. So what then do we need? Yeah, that's the answer to this question. So yeah, take a look at that. But often we write the answer with the positive exponents, and we have that. But yeah, I mean, it can be written 14 by 1 is 14 divided by 3x to 1/3 minus 10x to the 6th power. That is the answer we have. So yeah, that's the answer we have. So we're done with that one. Let's look at the next question. I might give you the next question. I want to see what we're going to do in 7.3. For which values of x will the tangent to this graph have a positive gradient? Okay, I know this one is pretty straightforward. It's 3 marks, or yeah, just 3 minutes or less. Just 3 minutes or less.
How do I find 7.3?
Okay, yeah, that's
It's saying for which values of x will the tangent to that graph have a positive gradient?
Yes. So want to find a tangent. A tangent would mean need to find the slope of a tangent, and therefore the slope of the tangent, if
Yes, you
is this,
find the
yeah,
derivative.
we find the derivative, well done, which is
And
3
then
minus 1, 2 plus
you equate
8.
the f prime x to 0.
Yes, because the gradient is positive, it
You
means,
equate that,
or yeah, it means that this one is minus 6x squared, and this is plus 8 is positive like this.
and then you're gonna get x to be
Yeah.
4/3. 4/3, right?
Yes, we're gonna get x to be 4/3, but we need to solve in detail. So we must solve for x out of 3. This is a quadratic. So it's like in question 1, if they give you this one plus 8 is greater than 0, how do you solve for x here? Because it reduces to this kind of a problem. How do you solve for x here?
Oh, so I'm gonna say negative 6x squared plus 8 greater
Yeah,
than 0. Like
yeah.
that.
Yes, greater than 0
They want,
because positive gradient. Okay, I have a positive gradient. So this is the gradient, but now if
so when they ask for positive gradients, you're gonna put it like that.
yes, if the gradient is negative, then we're going to make it less than 0. And this would
Oh,
mean, yeah, this less than 0 would mean like a negative gradient. Okay, now dealing with the positive gradient, okay, we make it greater than 0. Then what do we do?
oh, so when they're asking, isn't it the first derivative, f prime
Yes,
x?
yes, because it's the
When
text. Yeah,
they're asking if it's gonna be a positive gradient, you're gonna say f prime x is greater than
0. Well
0, right?
done. Yes, yes.
And then um the second derivative is concavity.
Yeah, the second derivative is concavity, or what we call obviously the inflection point.
Yes.
Right. So the inflection point or concavity in terms of whether a curve is concave down or up. Concavity. Concavity. Okay, now we're here. I want to solve for x here. Okay, so here you can divide through by -6, getting x squared minus
So
8 out of
it's
6
gonna be
less than 0. Okay, divide by negative
x
number again, the inequality changes direction, which means it is x squared minus 4 out of 3 is less than 0. Get the
x squared
point.
minus 4/3. Why?
If you divide through 8 and what is the common factor between 8 and 6? It's 2. If you divide both, what is 8 divided by 2? Then you get 4. Divide 8 by 2, you divide 6 by 2, you get a 3, right? So obviously that gives
Oh,
us, yeah,
okay.
that gives us x squared minus 4/3 is less than 0. But we must solve for x here. Okay, because it was greater than 0, but we divided by negative number, the negative number changes direction of the inequality from greater than to less than. Okay, so
And so it's
yeah.
going to be x squared is greater than 4/3.
Yes. So, I mean, solve for x here. Let me just give you
And
a task.
then
I want to see what you're going to get.
also
I want
it's
to see
going
what
to
you're going to get.
be
Yeah. I'm just giving you a minute.
x is bigger than I got I'm getting a square root.
Oh, you're getting a square root. Yeah.
It's a square root.
It's a square root. So, yeah, it's a square root. So this is like a difference of two squares. And why? So I wanted to see what you're going to do, but there are two ways to do that. So you can change 4, you can write as
Oh,
2 squared, and then you can put the 3, you can write as square root of 3.
okay.
So this is like a difference of two squares, meaning we have
And so
x
you can also
like
say
this.
open brackets x plus 2 over square root 3,
Yes.
then x minus 2 over square root 3.
Yes, 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 definitely. So obviously, I mean that
But then here, when I didn't use that, I got 2 square root 3 over 3.
you got you got 2 square root of 3 over 3. Right, it's correct, it's
Yes.
correct, it's correct.
Oh,
Okay, because use your calculator and all that. You see, the denominator is rationalized. Okay, this one is rationalized denominator. We have the square root of the denominator, but if you rationalize the denominator, then this is going to be 2 to the square root of 3. Okay,
so
now,
what happens if you don't rationalize?
well, the answer is the same. Doesn't matter. So yeah, the answer is the same either way.
So if you don't rationalize, they won't penalize you.
Okay, that's a good question. If you don't rationalize, I must indicate that the examiners themselves did not rationalize in the marking center for this question. They did not. So you see, the examiners themselves went through this in the marking center, and we're able to see that here they're able to get the critical values. So the critical values are x to the square root of 3, x minus 2 to the square root of 3. Okay, so the examiners did not rationalize. That's a good question. If they rationalized, they did not. I must indicate up front. Okay, so now at this point of this one is going to have a minimum vertex. Minus 2 over the square root of 3, 2 over the square root of 3. So we're looking for these negatives, or it is negative here. Okay, so yeah, it is negative between these two guys. All right, so yeah, so this will be the answer. But yeah, but you see, the answer is can be written nicely. It's not very nice like this, but examiners left it like this in the marking center when the metric paper was marked. Okay, but now you can rationalize this. How do you rationalize this? 2 to the square root of 3, you multiply it by the square root of 3 over the square root of 3. And you have 2 over the square root of 3, you multiply it by the square root of 3 over the square root of 3. Get the point? Okay, so this is minus 2 to the square root of 3. 3 is less than x, less than 2 to the square root of 3 over 3. Okay, so this is the same. Yeah, but the examiners left it like this. But the student can write it like this as well. It's the same thing. Because the student would have rationalized like this to get this answer one green. So in the end, then the student would be like given the same marks. Yeah, the examiners themselves. You see, in mathematics, it's not good to leave an answer that's not rationalized. Okay, so I mean, truth be told, because if you divide if you leave the square root in the denominator, it means the number is hard to estimate. This is the square root as well. Okay, it means the number is difficult to estimate. You leave the answer as x equals 2 over square root of 3. What kind of a number is this? But if you rationalize square root of 3, and then you have x 2 to the square root of 3, and you have out of 3 like this, so the number is the denominator is the whole number, and the square root of 3 is at the top. So it's a number that you can easily estimate and say it's approximately something. So, however, there's no hard and fast rule unless otherwise the examiners themselves were very nasty in this question. They left their answer unrationalized, but yeah, it is just that rationalizing would have required extra steps. They provided only 3 marks for that. So yeah, but yeah, they gave full marks. They themselves, they should like this. Okay, but yeah, just take note of that. Make sure you understand. Let's look at the next question. Right. Okay, now the next question is question 8.1.
So is this
Yes.
one question 8?
Yes.
Must I do it now, or is it homework?
I'm just thinking because I'm looking at the time. We need to stop at 6, you know?
Yes.
And it's like 6 minutes before the time now. What do you think? Maybe I give you this as a homework and you try.
Yes, I'll do it as a homework.
Okay, good. Right, let me give you this question 8 as a homework. Okay,
Yes.
because it's going to be available on the slide, and you're going to see 8.1, and 8.1 is given f of x equals this one minus x cubed plus 6x squared minus 9x plus 4 equals this. Determine the coordinates of the turning points of f. Draw a sketch graph of f. Clear label all. I'm just reading through because when you get the video, then you're going to be able to, the question is going to stay for some time and for you to do the things, because otherwise, if I just cut it short now, then it's too many questions and you have to pause the video, obviously. But yeah, I need to draw the sketch graph, use the graph to determine the values of k, for which this is true. The line g of x equals x plus b is a tangent to f at the point of inflection of f, and calculate the value of theta. Now, the value of theta is a very interesting one, this one. They're bringing the value of theta, which comes in analytical geometry, the angle of inclination. The acute angle formed between g and the x-axis in the first quadrant.
Oh, okay.
Yeah. So yeah, but this is the sort of question that you'll have to try. Then you can send me your attempts, and then I'm gonna mark it. But now, I mean, this question is it's a sort of will sort of be the last question because it's close to our cut-off time now. And then after you send me this, I'm going to mark. It's a very interesting question, but a little bit tricky. There are tricky
Okay.
parts. Like, I'm interested in seeing what you're going to do with 8.3. Use the graph determine difference of k for which this kind of an equation will have 3 real and unequal roots. So I'm interested in seeing how you're going to do this question. But obviously, we would have sketched, we would have drawn a sketch graph of f at 8.2, and then you're going to try this one, 8.3 for 2 marks. All right, I must thank you, Newa, for joining us. It was awesome having a discussion with you. You're gonna try this
Yes,
question,
thank
and
you,
then
sir.
you're gonna send it to me, and then I'm gonna mark it, and then there are more things. Then I'm gonna because I'm planning that we gear up. We need to step up. We need to become very serious with doing more questions and more questions in an attempt to prepare for the exams. But I'm sure that I will share a lot of the plans on the WhatsApp group. And obviously, with the June holidays, I'll be interested. Yeah, we'll talk about the June holidays. There's a lot of plans that are picked up. I'm planning that from the 17th of June until the 10th of July. We make it an intensive revision period. Okay,
Oh, okay.
the 17th of June, which will be this coming Monday. We make it intensive revision. Okay, meaning from the 17th of June, there's gonna be lots of math and physics, like every day. If you are busy, you can tap in every day because you see, I'm taking advantage of this period because most of the kids will be closed. Okay, the schools will be
Yes.
sort of closed, and most of the kids will be free, except those who are going to be having their winter school programs in their schools. Okay, but now, I'm just highlighting that. So, it will depend. But now I'm proposing that I'm going to be active every day for the students who are affiliated to our program to make sure that they can learn a lot of the term 3 work and term 4 work, and then exam preparations, and revision of term 1, term 2 work as well. Okay, but thanks a lot, Neo. It was awesome having a discussion with you. We'll talk more on WhatsApp. Have a good evening, and
Okay, thank you, sir.
goodbye, Neo.
Bye. Bye.
Goodbye, Neo.
Bye.
Goodbye. Thank you.